Okay, we all ready? Hello, welcome back to Lecture 6 of Introductory Astronomy here at Michigan Tech, and whoever wants to see this throughout the world. We'll be traveling throughout the inner solar system today. First, though, something to ponder, or to keep you awake, is the what is this for today. And what is this is a picture of something found on, well, I'll tell you what it is right now. This was found on Mars. And the question is, what is it? And we will get to that sometime during this lecture. And going on, what is going on here? Who is this guy? This is Introductory Astronomy, a class being taught for credit at Michigan Tech. It's called PH1600. Here, if you're trying to find it in the catalog. This is the 6th lecture. If you're still with me, which you probably are if you're hearing these words, good job. So today we're going to jump off, and instead of doing phases of the moon and things like that and the whole universe, we're going to look at the inner part of our solar system. Next lecture, which will be Wednesday, will be the Earth and the Moon. So this is originating from Michigan Technological University, which is in the Upper Peninsula of Michigan, and that's where I am a professor. I am Robert Nemiroff. And if you're taking it for credit, again, we do this every time, I say that you need to go to, and you still need to go to, courses.mtu.edu to take the quizzes and to get credit. You never have to show up, but I like to thank the people who show up. And to encourage people to even show up more, I will say that either before next lecture goes on the air or after next lecture goes on the air, I will be giving one of the quiz questions away. So if you're watching this during the week and you want to know what one of the quiz questions will be, come to the actual lecture. This is an experiment to see if that induces people to show up. We do have a nice crowd, though, the studio audience. So what is it if this course is completely online and doesn't require a textbook? Because it doesn't. All you need is Wikipedia and APOD and a browser and your own curiosity and the ability to stay awake for more than a few minutes at a time. You're responsible for the lecture material that I will review here. That is the most important thing, this lecture material. I will list the Wikipedia entries that you will be responsible for. Most of the time, it'll be just the Wikipedia stuff that I've said in class, but you really are responsible for those Wikipedia entries, even if I don't talk about them in class, except if it has higher math. I don't need you to derive the origin of the solar system from first principles or something like that. You will also be responsible for the astronomy pictures of the day posted during the semester, all the way from September 1 to December 15, I think, and I will be reviewing those on a weekly basis, and since this is a Monday and not a Wednesday, I review them on Wednesdays. So none today. To get credit, you should be completing the online homework quizzes. 1 and 2 should already be done. And 3 should be online and should be completed real soon. And to get those, of course, you go to the standard course webpage, which I think goes through a program called Blackboard at courses.mtu.edu. There's a tiny bit of mail before I get to the actual science. One bit of fan mail from the United Kingdom. Someone there likes the wiki part of it. He's a devotee of Wikipedia and APOD. And actually in this morning's mail I got someone from Jeffrey Landis from NASA Glenn Research Center in Ohio. Points out a problem. So I'll be reviewing today's APOD actually on Wednesday. But in today's APOD, I imply that a solstice, which is today, by the way. So today is September 22nd. It is a day of equal day and equal night. So from here on until the next solstice, the nights will be longer than the days. And we talked about that last week, and we're reviewing that through the APODs on Wednesday. But Jeffrey writes in to say, equinoxes only occur midway between solstices if you happen to live on a planet with an orbit of eccentricity 0. So that's true. The eccentricity is the amount of ovalness of the orbits. This is a high eccentricity ellipse. A circle is, as my best effort at a circle, has no eccentricity. So that's true. The Earth's however, has relatively little eccentricity, and so we can get away with it. And he points out that the fact that it's not midway between is sort of hidden by the uneven month length of the Gregorian calendar months. So interesting fact. Things can be debated about individual apods. If you go to any apod and you click on discuss, almost always that day's apod is brought up for discussion and people point out things they like about it, don't like about it. That's where a lot of nitpicks occur in wording and things like that, which is fine. I don't go back and correct them all, or even many of them, but as long as they're generally correct. Very small wording choices don't always bother me. All right, so the Wikipedia entries of today are Mercury, and you have to this time include planet. I mean, you would probably pick out planet and not the car by yourselves. So there won't be any Mercury car questions on the quizzes. Venus, turns out, it just goes with the name. Mars, and I picked out one of the landers being talked about this lecture, the Phoenix lander. You should look that up. That's a good one. So we'll talk about that later today. So these are called the terrestrial planets, for Earth-like planets. So the terrestrial planets are Mercury, Venus, Earth, and Mars. The moon, Earth's moon, is sort of a terrestrial planet in that it's bigger than still smaller than Mercury, I think, bigger than Pluto, bigger than, comparable to some of the largest moons in the solar system. And so sometimes the Earth-Moon system is called a double planet system, but we're going to exclude that from this image and discussion. So here's the Earth right here. You might recognize it. It is the classic Earth picture that is constantly shown again and again, sometimes called Big Blue Marble. You can see Africa here. There's Arabian Peninsula there. So Earth is, as I like to say, is the biggest rock known. Consider Earth to be one rock. The second biggest rock known would be Venus. Talk about that. There's lots of extraterrestrial planets being discovered now, planets outside of the solar system. This is Mars, and this is an image of Mercury, composite image. So these planets are mostly composed of rock. When we get out to the outer solar system, we'll find that the planets are mostly composed of gas, mostly hydrogen, some helium, other gases. But here we have mostly rock. These are big rocks, and these planets are so massive that they form themselves into a sphere. Now, what are the chances that you would just get a sphere out of a big rock? I mean, wouldn't it just be some strange shape? And the answer is, well, there is a mass above which for rock densities is around 1,000-kilometer radius, past which you get, even if you tried to make it into so let's say you got together a Mercury-sized mass, and you just made a really cool shape and you're proud of like this, okay? And you let go, and you go to tell your friends, and you come back. When you come back, you'll have a sphere, because the gravity is so strong that it pulls rock into a sphere, nearly a sphere, at that mass and density. So these guys all have enough mass to pull themselves into spheres. And in our solar system, we go through a slight transition, and we'll see Wednesday that there's actually a dwarf planet that's right on the edge of that. And so these planets are roughly spheres. Now, they're not exactly spheres because they rotate. And when they rotate, even though we think of the Earth as solid, it's somewhat of a liquid, because if we rotate it fast enough, it bulges in the center. It's true of any of these objects that rotate fast enough. And only Earth and Mars rotate really fast enough to have that effect. They bulge in the center because they can also be considered a liquid. So it just comes to mind that if you just have some water and you just throw some water into the air, if the water is small enough, then surface tension will pull it into a sphere. So there will be a force so if you had your little water drop up in the air and you made a nice little artistic shape and you wanted to go out and show your friends and you let it go and it dropped, by the time you came back, it'd be a sphere. because surface tension would pull it into a sphere. However, if you just take a water balloon and you smash it on top of a building and you watch it fall, all the water is not contained into a sphere, because at that point surface tension is not strong enough to pull all the water into a sphere. So that's another kind of thing. When a global force like that takes effect, it pulls things into spheres. So in the solar system, it's gravity. With small droplets of water, it's surface tension. So here is our terrestrial planets, again, looking down from above. So Jupiter is not a terrestrial planet, but it's shown there for scale. Here you see the asteroid belt, where there's lots of things that are smaller than planets, so we're going to exclude them right now. Most of them are pretty rocky, although some of them are pretty icy. So inside of that, there's Mars, Earth, Venus, and Mercury all around the sun. And you can't see them, they're too small. And as I've said, you can't see the orbits. They're just drawn in, so you can see them there. We'll get to the outer solar system next week, including Jupiter, Saturn, Uranus, and Neptune, and even Pluto, which is now a dwarf planet. And sort of the outer solar system equivalent of this Jupiter belt with the asteroid belt, which is the Kuiper belt, and new objects like Sedna and dwarf planets. So we'll get to that next week. Let's go closest to the sun. Not a fun place to visit. You would melt. It's the first rock out from the sun. There used to be thought that there was an even closer planet. And does anyone remember the name of that closer planet way back in the mirages of trying to look near the sun for planets? It's sometimes tough to look near the sun because it's so bright, the color of the sun, but it was called Vulcan. And it wasn't real. So many times in science, people think they've discovered something, and then there's a battle, and there's a decision to be made by scientists. Do you have enough information to declare you have a discovery? And if you do, you should declare that, and you've made a great discovery. However, there are people who are working down the block, down the street, the next city, the next continent, who might be working on the same thing, and if you have a discovery, they might have the same discovery, and if they announce it first, they'll get most of the glory, and you'll be an asterisk, also found by. So nobody wants to be an asterisk. Everybody wants to be the original discoverer. But you're never sure if what you have is real or not. So there's this fine line that's crossed from, wanting to be first and not wanting to be wrong. Those two things battle it out in science. And so I think the people who declared that Vulcan was the nearest planet, well, they were wrong. So fortunately, science or history isn't usually so cruel as to bring up their names all the time. But the confirmed nearest planet to the sun is Mercury, and it's pretty easy to see. You can see it. We'll show in pictures later, pictures on APOD, on some evening nights and some early mornings without a telescope or anything. Mercury has the problem of being really hot. It has very little atmosphere to speak of. It orbits the sun once in 88 Earth days. Once it was thought that the rotation rate and the orbit rate was the same. This was about 2 or 3 decades ago. So we're still learning about Mercury. We still learn things about all the planets. Some people think that we know essential science knows everything it has to know, and so scientists and professors just get up and just tell you what's known, and then you write it down, and then you know it. But that's not the way science works. We're learning new stuff all the time. We're learning stuff about Mercury all the time. We're learning stuff about the Earth all the time. So science is a frontier where we know more and more. And then what happens is, professors get up and pretend we know it all because it's fun and makes us seem powerful. But we don't know. So a couple decades ago, professors like me were professing that Mercury rotates and orbits the sun at the same rate so that it was locked to the sun, so that one, just like the moon, always points the same face toward the Earth. Mercury, they thought, always had the same face toward the sun. So if you were on the sun face of Mercury, it was really hot. Talk about hot, it was really hot. And the other face, the whole planet's kind of conductive, so it would be kind of cold because it never had the sun in the sky. So it would be kind of different. But you could try to live on the terminator between sun and not sun, but you kind of have to move. Mercury probably librate. You have to get it just right. But now we know that there's a 3-to-2 orbital resonance, not a 1-to-1 like our moon. And so it rotates, Mercury rotates in 59 days and orbits in 88 days. Actually, we probably learned that more than a couple decades ago, because now I'm realizing that Mariner 10, although Mariner stands more for Mars, the Mar in Mariner might give that away, it went to Mercury. So we've known that probably for 5 decades, that Mercury didn't have the same orbital and rotating rate. And Mariner 10 took lots of great pictures of the sun and were the best pictures of the sun up until this past year when the Messenger spacecraft arrived earlier this year. Messenger zipped by Mercury, we'll talk a little about that, and will actually orbit Mercury in 2011. Okay, so this is the moon. That's available a lot. This is Mercury taken over many successive nights, so you can see Mercury. Many times my experience with Mercury is you go out with a friend and just after sunset, because I'm too lazy to wake up early in the morning and try to find those things that are just before the sun. Typically, sometimes I will, but it's kind of rare. So just after sunset, where the sky is still somewhat bright, you go out with a friend and you start trying to find Mercury, because you see on some sky chart, maybe from some astronomy magazine, where it would be. And so you look and it's actually difficult to find. And you say things like, oh, I think that's it. No, no, that's not it. And then it's sort of a competition between you and your friend. And finally you agree that there is some spot, right there that is somewhat dim, but once you get used to seeing it, you can find it again pretty quick. That's until you turn around or you walk away and you get disoriented and come back. Then it takes a minute to find it again. But if you just turn your head, you can find it again. And it's a point of light a little bit brighter than the ambient light near the horizon. So on successive days, now Mercury is only seen just after sunset and just before sunrise, because Mercury is very near the sun. So if it's very near the sun, you can't see it at midnight, because it's near the sun, and the sun is on the opposite side of the Earth at midnight, and you're not on the opposite side of the Earth. So if you look up at midnight, you're not looking at Mercury. You're looking in the wrong direction. You have to look near the sun to see Mercury. So near the sun occurs, now if you try to look during the day, theoretically, if you could somehow not burn your eyes out because of the sun, you could find Mercury. However, due to how bright the sun is, you'd burn your eyes out before you found Mercury. So after the sun sets, it gets darker, and the sun isn't right in the sky, so that's the time to really see it. You have an hour or so after sunset to see it, if it's visible that time. It's not always. It might be only visible before sunrise. So here we see Mercury day after day climbing in the sky. It was probably cloudy that day, and higher and higher. Here's the highest it got. And then in subsequent days, it got more faint. So it's kind of fun to go out and see. You don't, need binoculars or anything. Just look it up on the web or something where it is when it's visible in the evening sky. And it's kind of fun to go out and see it. My experience is relatively few people have gone out to see it without being prodded. Who's seen it in this studio audience here? One. Okay. All right. Mercury, every few years or so, will transit the sun, which means it does its own little eclipse. So you can play your own Where's Waldo here, and in each of these frames, there is the planet Mercury. These frames are taken, I think, from the SOHO spacecraft, which orbits the sun near the Earth. And they're in ultraviolet light, so they're taking images of the sun. So see if you can find in all 4 panels, I won't give it away just yet, where Mercury is. I'll whistle Jeopardy music. Okay, that got boring. Here's Mercury here. See it? Just curious, studio audience, who sees Mercury in this panel? Okay, most people. Okay, third panel. Who's looking at the third panel? Third panel, who sees it? Anyone? Keep looking. Extra few seconds. Ready for the bonus round? Here it is. Last one's easiest. Here we go, last one. Where is it? Anyone see it? All right. Thanks for humoring me and raising your hand. Yep. Okay. Don't learn a lot when Mercury transits the sun. It's one of these things that amateur astronomers, if you have the right equipment to look at the sun, it's fun to see, but you don't learn a lot of science when that happens. Here's a Mercury sun sequence. So every few minutes, I guess, picture of Mercury. This is the sun in optical light. This is a sunspot. I don't know what this is. It's confusing. But this is Mercury. So Mercury doesn't always go right across the center of the sun. That would be silly. Although when I think about it, I would think, yeah, it would go across the center of the sun. But after I see it not goes across, I say, oh, yeah, that makes sense. So here's a close-up picture of Mercury from Mariner 10, the previously best Mercury spacecraft. Surprisingly, Mercury looks a lot like the moon. So you would know you were in Mercury and not the moon because it would be a lot hotter and the sun would be a lot brighter. But there's still lots and lots of craters. It is a barren, hot, cratered world. This is southwest Mercury, again, Mariner 10, just a different, shows the contrast to the eerie darkness of space. Lots of craters on craters. Mercury has what's called an old surface. It's got craters on craters and craters. Now, that's not to say the rocks on Mercury are any older than many of the rocks on the moon or in certain places on Earth, but Earth has a lot of erosion and weather that tends to knock out craters, but Mercury doesn't have much that knocks out craters. So this is the Messenger launch in 2004, and Messenger went zoom. Pretty cool to see. Here is an image from March of this year, 2008, and this is Mercury in exaggerated color. You can see the text, go to the March 19th APOD. Mercury is pretty much black and white, but in this image, the is heavy in infrared light, just a little more red than the eye can see, and it brings up the brownish hue that isn't typically visible. It shows that Mercury can be a pretty beautiful planet. And there are big crater features, craters. I think the Chloris impact basin, I can't tell well from this image. I think it's up here, but I might be circling the wrong area. That is one of the bigger impact basins in the solar system. So Mercury has been hit by lots of rocks. Each of these craters means it was hit by something big. Spidership crater, so this is taken again by, I forgot to reformat this slide, by the Messenger spacecraft. Here you see there's lots of troughs leading out, and it's unclear whether this impact crater created these spider-like troughs. Unknown and being studied. The relatively light parts, why some parts of the ejecta are relatively light and some are dark, is also being studied. This is a fault on Mercury. There's several faults on Mercury. Again, unclear exactly why. Possibly Mercury cooled at some point in the past, and when it cooled, the crust that goes around Mercury condensed, the whole planet condensed a bit, and so it cracked and caused these faults that go through craters. Here, I think, is Chloris impact basin up close. So something really big, possibly an asteroid, struck Mercury probably, billion years ago or more. Okay, so to find out more about Mercury, go to Wikipedia. There's lots of good information there. Venus is next on our planet parade. It's the second rock out from the sun. Like Mercury, there's no moons. The size and mass of Venus are similar to the Earth. They're sometimes called Earth's twin planet. It's hard to see the surface of Mercury, though. You can see the surface of It's very hard to see the surface of Venus. It's easy to see the surface of Mercury because there's almost no clouds. But Venus has a very thick atmosphere, mostly carbon dioxide. Speculation is that if we here on Earth continue to emit lots of greenhouse gases, then we will, and particularly carbon dioxide, we will start reflecting back enough light to create a runaway greenhouse effect, and the Earth could become like Venus. Venus is not a good vacation planet either. We'll discuss that next slide. Venus rotates relatively slowly. It takes 243 Earth days, and it orbits 224 Earth days. So it's slow rotator, unusual rotator. We'll go into the details. The atmosphere is very interesting. The surface temperature on Mercury, on Venus, if I can get my planet straight, is 750 kelvins. So that's many degrees Fahrenheit and many degrees Celsius. too hot to sit there and be comfortable, too hot for your air conditioner to work. If that didn't bother you for some reason, the pressure would crush you. So the problem with landing things on Venus is that they tend to get crushed by the pressure, and they tend to heat up and melt because of the temperature. And again, this is caused by the greenhouse gases. But this didn't stop the then Soviet Union from launching the Venera satellites in the 70s and 80s. And they actually succeeded in landing spacecraft on Venus, and they lasted for a couple of minutes sometimes before they didn't want to work anymore. And there are pictures, and I will show you a picture from the surface of Venus. It's pretty interesting. Recently, the Venus Express, the European Space Agency, has launched the Venus Express, and it arrived in 2006 and has been studying the clouds of Venus in great detail, and I'll have a little bit of that in the pictures coming up. So you can see Venus in the sky. Venus is many times the third brightest thing in the sky. The brightest thing is the sun. Many people might have noticed. The next brightest thing is the moon, and here it is. The next brightest thing, frequently taken for a UFO, as I mentioned last time, is Venus, or for an airplane. The way I tell it's Venus and not an airplane is, as I said before, I stand there and I watch it for a couple of minutes, and if it doesn't move with respect to like nearby trees or something, seems in the same part of the sky, then I'm reasonably sure it's Venus. This is Jupiter. Next week, this is a star. This is an airplane. So this is called a quadruple, I guess, informally, and a very beautiful picture, I think, was sent to us of a mom and three kids out at the lake, picture taken by Grandpa looking over the Great Salt Lake at 4 celestial objects. So anyone can go out and see Venus without binoculars or anything. It's really bright. There is something called the belt of Venus, which I don't know where else to put in the course, but I'll put here. It's this sort of purplish, pinkish belt. Everyone's seen it, but few people have noticed it. So when the sun is setting or has just set below the horizon, and there is in the direction of the sun, when there is a reddish horizon in particular, then if you look opposite that, you will see the shadow of the Earth here. And as the sun sets, the shadow of the Earth is rising. And so this part is illuminated by the sun. This is sunlight. This is shadow, but it's not dark shadow because the Earth's atmosphere makes things fuzzy. And in between the sunlight region and the shadow region is the belt of Venus. And it's called the belt of Venus because Venus will frequently occur at the same altitude as the belt of Venus. It's somewhat controversial as to whether the belt of Venus goes all the way around the sky. Once in an airplane, I checked it out, and it seemed to me that it did. So even after the sun sets right near the sun, the belt of Venus goes right around to be very near the sun. But it's classically referred to as the other direction from the sun. Venus, on more rare occasions, transits the sun, as I discussed last time during eclipses. Here's a picture of Venus transiting the sun, unlike any cloud, perfect circle or nearly perfect circle. And here is the space station, which doesn't look... so the space station is taken on a time-lapse image, sort of strobe effect. But Venus is taken in one shot there. An unusual picture to get them both, very unusual, in front of the sun. Okay, I showed this last time, one of the more artistic images. Beautiful images of Venus, right here, spot the planet in front of the sun, and there's just normal clouds that are the thing that usually block out the sun from the Earth. So Venus, here's the sun. Let's see, here's the orbit of Venus. And here's the orbit of the Earth, which I'll make an ease. So Venus goes around like that, Earth goes around like that. Venus goes faster than the sun. So when Venus zips through in front of the sun, it appears to go backwards on the sky. And so if you just plot the position of Venus all the time, you will eventually get an S on the sky. This is an image of Venus Express arriving at Venus. This is, I think, taken in ultraviolet. so it's colored blue. Venus is pretty much featureless. But here, in optical light, in ultraviolet light, you can see features. So this is also somewhat ultraviolet, but mostly toward the optical. Here you can see more or less the real color of Venus. So the Magellan spacecraft went to, in the early 90s, I think, orbited Venus, and main intent was not to study the clouds of Venus, like Venus Express, but the surface of Venus. And the way they did that, how can you possibly see this through those thick clouds? Radar. So Magellan had a lot of radar, was bouncing a lot of radar off the planet. We can bounce radar off the planet from the Earth, actually, but not as good as Magellan could do it. And so this is what's under the clouds. And there's lots of big volcanoes on Venus, and lava flows, and unusual surface features that are not completely understood. So let's get to some of these. This is conical circular surface features that are thought to be volcanic in origin. So this is a computer reconstructed image of the surface of Venus as reconstructed from radar bounced off from Magellan. Some of these attributes are called corona. This is Ateti, I think is pronunciation, I'm guessing. Corona. This is not real. This draws the eye to it like, oh my goodness, there's something crawling on Venus, but that's just an image artifact, so that's not real. This is the interesting volcanic features that are around Venus, and the origin of which is not well understood. Again, this is known from Magellan. Here's an indication on the surface of lava flow. Here you see there was some structure here, and then there was some structure that went over it. And so the flowing structure that went over it is thought to have been some sort of lava. So lava has flowed on Venus. This is a computer reconstructed image of down near the surface of Venus, the 100-kilometer terrain. So the resolution is 100 kilometers. Surely there's small craters or some kind of other features that are not seen here. So a lot of the texture is computer reconstructed, but the height of the terrain, the hilliness of the terrain in this part, this is an automatic feature. That's not real either. But this part, you get a feeling for the height of the terrain and the hilliness of the Venusian terrain. This is, I think, taken in early in the 1980s by one of the Venera spacecraft that the then Soviet Union landed on Venus. So here you can see part of the spacecraft, and you can see some rock formations that are there. So when we go down to the surface of some planet or moon, many times what we will see are rock or rock fragments, sometimes made of different things. This is probably made of rock similar to Earth rock. This is an artist's depiction of Venus Express in orbit around Venus, so you know what kind of spacecraft are going out there, so you can visualize. So here are the solar panels drawn there. This is communicating with Earth, and here's some of the computer equipment that will be doing the. Well, there's another antenna too. The analysis of what's going on. Here's a picture from Venus Express that's studying the clouds. This is a daylight picture in somewhat ultraviolet. Here you can see cloud bands here. You can also see this is over the south pole of Venus. This is a thermal image, so you can see what's hot on Venus. And what's interesting is that there is essentially a hurricane over the south pole of Venus that seems to be relatively steady. It does not come and go like our hurricanes. And it appears to have two eyes to it. So not predicted beforehand, a very unusual feature being studied. Studying the clouds of Venus, the weather of Venus, helps meteorologists better understand the clouds and weather patterns on Earth, too. Okay, out to Mars. Mars gets the best publicity of all the inner planets, excluding the Earth. It's the fourth planet out from the sun. For a while, people thought that it was inhabited by Martians. It orbits the sun every 687 Earth days, but its actual day on Mars is very similar to the day on Earth. It's 24 hours and 40 minutes. It has a thin atmosphere. It does have an atmosphere, which is also mostly carbon dioxide. It can get very cold there, minus 140 degrees Celsius. So Mars is thought one of the best places to put astronauts. But at certain places on Mars, you got to watch out. And certain seasons on Mars, it's going to get very cold. And if there's a sandstorm, then you might be blocked from receiving warming sunlight. However, on its warmest days, it's somewhat hospitable. Although you can't breathe the atmosphere, 21 degrees Celsius is, not far from room temperature. It has a very thin atmosphere, 1% that of Earth's. So you can't take off your helmet. But assuming it's warm, and you have a spacesuit on, you can walk around. Which one of the reasons why Mars is one of the main targets, and why NASA has frequently targeted Mars as a place that NASA would like to go to. The problem is it takes a lot of money to go there, and a long time. So you can take images of Mars from the Earth. You can see Mars in the nighttime sky. It doesn't take any telescope. It looks a little bit reddish. So here you can see with a small webcam, you can see the polar caps. And you can see the some different color sand. Mars also goes Mars goes retrograde. So when so here we have the sun. Here we have the Earth going around the sun. I'll make lots of E's to show that. And then we have out here we have Mars going around the sun. I'll put M's to denote Mars. So the Earth and Mars go around the sun. So when the Earth passes Mars, since the Earth goes faster than Mars, when Mars is here, the Earth will zip past it, and Mars will appear to go backwards, and it's called retrograde motion on the sky. So Mars will appear to go backwards with respect to the stars because the Earth is zipping in front of it. And then for most of the time, the Earth goes around the orbit like that, and you see regular Mars motion on the sky. I think this is Uranus, retrograde motion of Uranus in the same image. It doesn't have to be a loop, depending on the relative, how the planes of the orbits line up. It can be another S-type or a Z-type shape, the retrograde. This would be the retrograde portion right here. Okay, so for a while, again, back to this theme in science that people think they've discovered things. So Percival Lowell and other people would look at Mars, and they would say, wow, there's vegetation on Mars. Now, they could wait for some kind of confirmation for this, but then other people would notice it, and they would become famous. So they went forward, and they say, look, vegetation on Mars. And they named certain things, and there were the vegetation was strongest here. It was most green, and not only that, but there were canals on Mars that were connecting these, and these canals were thought to be irrigation pathways to carry water to keep the plants green. And so people were excited about that. And then later it was discovered that, well, there was people worried about Martians coming to Earth at some point. So there was War of the Worlds where people were concerned that the Martians were coming, and now we have movies about that too, mostly joking. It's interesting to see how the Mars of back then compares to the Hubble image or a close-by image of Mars today. You can see that the Mars of yesterday, of 100 years ago, has similarities to actually what Mars looks like. So you can see this basin here, the Hellas basin. You can see the relatively dark features here. They're real. What's not real are these things. They're just on the edge of visibility. So he assumed they were there. He would convince his friends they were there. But they weren't there. There are no canals on Mars that are built by. There's no indications that there are Martians on Mars. Mars may have held life once. We're trying to find out. But there's no clear indication that it ever did. Here you see the polar cap, and there is a polar cap. But they published too early. They should have just reported what they saw, which were dark areas and light areas, and we would have confirmed that with today's technology. So ads of the time speculated that not only are there people on Mars, not only Martians, but there's people, but they want Kirk's soap. See? So it's part of the America family, see? Okay. Mars has 2 moons. Phobos, which is really cool, and Deimos, which is strange but also somewhat cool. They orbit Mars, strangely enough. And let's get to what they look like. Really cool looking Phobos. Strange moon. Not massive enough to be spherical. You can see lots of craters on it, though. Big craters. Big things hit it. It's got this texture, these liney texture. I'm not sure if scientists don't really know what caused that at this point. The strange thing about Phobos is it orbits so close to Mars that usually Earth's moon, the rotation of the Earth is so fast that the moon rises in the east and sets in the west just like everything. And that's true for Deimos of Mars, but Phobos is so close to Mars that it's faster than the rotation rate. So it's actually somewhat close to it. But you can see it rise in the west and set in the east. It's from some locations. It's also so close that it's moving closer and will eventually break up. And it is thought that for some time Mars will have a ring, which will be pieces of Phobos, and then it will rain down on Mars, making any potential Martians unhappy with lots of debris. That will happen in about 100 million years, it's speculated, that this moon is doomed and it will crash to Mars. This is the other moon, Deimos. Also somewhat strange looking, not spherical. Probably has a significant regolith, which is dust, and there's impact craters there too. This is Mars itself. This is the Grand Canyon of Mars. So I actually brought this is an apod, as all these images are, and so this Grand Canyon, my notes say, which I brought with me, which I don't usually bring nights, extends 3,000 kilometers, spans as much as 600 kilometers, and delves as much as 8 kilometers deep, this Valles Marineris, the Grand Canyon of Mars. By comparison, the Earth's Grand Canyon in Arizona, USA, is only 800 kilometers long, as opposed to 3,000. This is 3,000. The Grand Canyon of Earth is 30 kilometers across, as opposed to 600 kilometers for this feature. And the Grand Canyon of Earth goes as deep as 1.8 kilometers, as opposed to 8 kilometers for Valles Marineris. So it is a very impressive feature. Also on Mars, you see some tremendous volcanoes here. Huge volcanoes, and since there's not a lot of plate tectonics on Mars, these volcanoes just get bigger and bigger. So some of the largest volcanoes in the solar system are also found on Mars. So there's Mars is hospitable enough to put things on there that survive. So we've put several spacecraft on Mars. About half the spacecraft we send to Mars survive. The other half turn off for different reasons. One reason being that kilometers and miles are not the same. But this one is one of the rovers on Mars. This picture could not have been taken. There was no Martians were able to come up and snap this picture. So this is a digital recreation of the surface of Mars with a laboratory picture of one of the Mars rovers. It could be Spirit or Opportunity. And these guys, they've been rolling across Mars for years now and taking pictures and going on little journeys and investigating rocks and taking close-up pictures. And so they're able to travel and see things. They can't travel across the planet. They can travel on the order of a kilometer or so. So they've been landed where there's lots of questions as to the history of Mars. And so even in this picture, you can see little things sometimes called blueberries, little nodules. And so when these rovers landed, they saw lots of these little blueberries and these little rocks. And there was a debate as to what caused them. They're now thought to have been accumulated during a wet era of Mars. Parts of Mars look like parts of Earth, and so we challenge the reader and the audience again. This is an interactive day. Which is Mars and which is Earth? So one of these is Mars and one of these is Earth. So who thinks this is Mars? Who thinks this is Mars? Okay, so we're pretty clever. So this is Mars. And this is a desert. I don't think it's Chilean. It's, I forget where this was taken on Earth. But we have areas where there are reddish rocks strewn in places on Earth too. So this is a better picture of Mars from the rolling robot Spirit, still on Mars, still going. This is another part of Mars that doesn't have lots of rocks. This you can see the heat shield of the spacecraft that came down with the rovers and then disintegrated, which is fine. It was expected. Here's where it landed, and here's a burnt up part. But also interesting is that a lot of Mars isn't lots of rocks. A lot of Mars is just barren, dark sand. And so here you see it in this picture. As you get near the poles, there can be different kinds of ice, carbon dioxide ice or even water ice. And there can be steep cliffs, and I believe these cliffs are about 2 kilometers from top to bottom. And it might be a fun joyride. You'd have to put on some, since the surface gravity of Mars is significantly less than the surface gravity of Earth, if you had the right kind of balloonish kind of equipment, you might be able to survive that. So it might be a future kind of joyride to go to Mars and jump off some of the cliffs. There are even bigger cliffs on Earth, but you can't survive jumping off them in any kind of reasonable. And there's even bigger cliffs elsewhere in the solar system. I think one of the moons of Uranus has a tremendously large cliff, which you could probably survive. Looking at Mars Express, again, from the European Space Agency, is also, well, it's different from Venus Express. Mars Express is, surprisingly enough, around Mars. And some of its pictures have shown unusual, seemingly plates covered by Martian dust. And it is speculated that these plates are water ice covered over. So it is known that water ice exists near the Martian poles, but how far it gets to near the equator is not known. And it is thought that if it exists near enough the equator, it would give past life a chance to have existed. So it's an exciting. Also, astronauts could go and tap into that water ice and not have to bring water with them. They could just melt the ice there. So here we see a crater near the North Pole of Mars, and in this crater is a pool, a frozen pond of water ice. If this had been exposed to the sun, it would have evaporated. Mars, see, they take lots of pictures of Mars, and it's almost always the same. But if you take close-up pictures, suddenly you start seeing these unusual dark streaks. They appear. And so it was strange to find that Mars is changing even on the time scale of years. And so it is found that these streaks are caused by these dust devils that pass. This is a relatively minor dust devil in this GIF movie, seen by one of the rovers, not expected to have been seen. So there are dust devils here on Earth. They're sort of like light tornadoes. The winds don't get close to what a tornado can do. But they can be annoying, and you can see them in different places on the Earth go by. They're dusty, and they have them on Mars. And the neat thing is sometimes they clean off a Martian spacecraft. Mars has big windstorms, global dust storms that can cover much of the planet in thick dust. So here you can see in one day on Mars, it going from relatively clear to the opacity here becomes very thick. And it becomes like nighttime during the day on Mars because the dust is so thick. And there are dust storms here on Earth too, but these things are really on a global scale on Mars. So the Mars rover, one of the Mars rovers rolled into Victoria Crater on Mars. So here is a digitally compressed image, compressed this way. And the rover rolled in here and looked around and found more about the wet past of Mars. So it is now thought that Mars underwent a significant wet period. So life might have developed then, but we don't see life now. We don't see any vegetation. It is thought that there could have been a phase where Mars developed life, and then things hit Mars, rocks came off Mars, landed on Earth. So life might have developed on Mars, but not on Earth. Oops, and I've gotten a little problem here. Let's see if I can keep going with this. All right, so here's a picture from inside of Victoria Crater. I want to hurry up so I can get to the next one. So this is the Phoenix mission, which just arrived on Mars a few months ago. And Phoenix does not roll around. Here you see a solar panel from the Phoenix mission. This is the landscape. And you can see some of these areas that turn out to be water covered by Martian dust. There's water ice there. So here you see it scooping things up, putting it in its little bakers, and to investigate the chemical part of what a really detailed chemical history, or not history, chemical analysis of Mars. So that's going on. One of the reasons for looking for this is looking to see if there is water ice under the surface of Mars, which there is. It's found. So here you can see in the next picture, this is water ice, cleaned off by the landing of Phoenix. And also to see if in the ice soil interface, whether there was ever a time when there could have been life developing there. So sort of investigating whether there's a possibility for life to have existed in the past on Mars, even if it's not there today. So that's one of Phoenix's main missions, to get more data toward better understanding that point. So back to this. This is sometimes called the face on Mars. And it is now known not to be Martians trying to erect a big picture of a human face to alert us humans. It is now known to be just a rock formation that just happened to have the sun illuminating it from the right point of view to make it look like a face. So just like clouds in the sky that look like turtles, they're not turtles. Okay? So this face that looks illuminated from a certain thing that looks like face on Mars, oops. This is a picture of it, a computer. This is what the mound looks like illuminated more fully in a computer reconstruction from Mars Express images. It is not a face. It is not a monument, regardless of current movies. All right, so that will wrap us up for today. And tomorrow, on Wednesday, we will not only review the astronomy pictures of the day, we will give away we will give away a quiz question, and we will talk about the Earth and our moon. See you next time.